Hi, my name is Andrea Montibeller and today I will present you some work and some preliminary results we just obtained in collaboration with Professor Giulia Boato and Cecilia Pasquini from University of Trento and Professor Fernando Perez Gonzalez from University of Vigo, Spain. As you probably know, nowadays GPUs get widely used mainly for deep neural network, affecting also the multimedia forensic research field. A classic example indeed is Noiseprint, a deep network aimed at solving tasks as source identification and tampering detection. However, this type of network are often required in courtroom cases, but they get limited by the legislation that consider them just a source of investigation and not a source of proof due to their not full explainability. I will present you then a way in which we can still rely on the powerful hardware and parallelization capabilities of the GPU without using deep learning for solving tasks as source identification. Generally, with source identification, we refer to that task in which we try to estimate from which device a certain media came from. To do this, we use PNRU, or photo-response non-uniformity, a scanned signal introduced by the sensor of our device due to its manufacturing process that can be extracted, compared, and matched with other PNRU extracted from other media coming, presumably from the same device. However, it is really sensible to spatial transformation. Indeed, when happens, for instance, during the pipeline of acquisition of our media, radial correction, digital zoom, and video stabilization correction, PNRU can get desynchronized one with respect to the other, even if the media come from the same device. To resynchronize the PNRU, then, we need to apply this model. But the problem of this model is the fact that we have a lot of parameters to estimate, difficult to do it in a short amount of time serially with a CPU. Fortunately, since GPU were first applied to computer graphics tasks, we know that they're actually pretty good in inverting this type of spatial transformation, or apply them. Indeed, as we show in this example in which we compare the time consumed of the same TensorFlow implementation run first on the CPU and then on the GPU, we see how the GPU is way faster in inverting radial correction and digital zoom or applying bilinear transformation, both on batch and single image due to its parallelization capabilities. Finally, we would like to present some results of our implementation for source identification of digitally stabilized video, which is still an open problem and that took inspiration from the state-of-the-art proposed by Giuliani, working only with AE frames. Actually, the algorithm is pretty simple. You just apply the initial grind search to the first frame in order to be able to invert the stabilization and maximize the correlation to this one, and initialize at the same time the predictor, which predicts the parameter able to maximize the correlation in the next frame, working in a round of a precedence estimation and exploiting their temporal coherence. Of course, improvement can be achieved and is our purpose to study better them. For instance, we will start trying to work with all the frames without throwing away information and weight that type of information. At the same time, we want to infer more information in order to reduce the space of research of our parameters and maybe modify the classifier, which at the moment is just an average correlation value. Unfortunately, I think that my time here is finished and I will be more than happy to answer any of your questions or doubts that I was not able to get during my presentation. Thank you very much.